Have you ever wondered what's really powering the smartest devices all around you? Well, today, we're going to look at a single piece of silicon that is absolutely changing the game. Microchip's PolarFire SoC. This isn't just any chip. It's packing some serious intelligence right where it matters most, at the edge.
I just love this quote from EE Journal because it is the perfect way to think about this. You've got these two amazing technologies. On one hand, you have a flexible, reconfigurable chip called an FPGA. You can think of it like a blank canvas for hardware. And on the other, you have a powerful, intelligent processor. You put them together on one chip, you get something way better than the sum of its parts.
So, this powerful combination is what the industry calls a system on a chip, or SoC for short. It's basically an entire computer system on one little integrated circuit. Now, Microchip's PolarFire is a fantastic example of this trend, but it's the processor they chose that makes it really special.
So, what is it that makes the PolarFire SoC stand out in such a crowded field? It all comes down to the processor. Instead of going with a traditional licensed design, Microchip made a really bold choice. They built their whole system around the open-source RISC-V architecture.
Okay, so what exactly is RISC-V? It's not a specific chip you can buy. It's more like a rulebook, an open standard that anyone can use to design a processor. You can think of it like the open-source software that powers the internet, but for hardware. And this freedom from licensing fees and design constraints, oh, it is a huge deal.
This slide really breaks it down and highlights the fundamental shift. On one side, you've got the traditional model, right? You pay a royalty for every single chip, and you get a pre-designed, pretty much locked-down core. But on the other side, with RISC-V, there are no royalties, and you have the freedom to totally customize the hardware. This just blows the doors open to a world of new possibilities.
And here's a perfect example of what that customization gets you. For things like industrial robots or automotive safety systems, you absolutely need deterministic performance. That means an operation has to take the exact same amount of time every single time without fail. With RISC-V, Microchip can fine-tune the processor to get this level of precision, something you just can't do with an off-the-shelf licensed core.
Okay, so we've got a highly customizable real-time processor. That's awesome, but what about AI? To handle the insane workloads of modern neural networks, Microchip built a specialized engine right into the chip, and it's called core vector blocks.
This thing is the AI muscle of the PolarFire SoC, and it's designed specifically to accelerate the complex math behind neural networks. The key word you want to remember here is flexible, and the magic that makes it so flexible is something called an overlay approach. So what is this overlay thing? Think of it like this. Instead of building a whole new custom piece of hardware for every single type of AI network out there, the overlay approach creates a generic, reconfigurable AI engine. This means the same physical hardware can run a network for image recognition one moment, and then on the fly, switch to one for object detection the next, all without having to redesign the chip. It's incredibly clever.
So how does this overlay approach actually work its magic? Let's pop the hood on core vector blocks and see how Microchip manages to pull off this incredible flexibility and performance.
All right, so from a high level, it's a pretty straightforward process. Data, let's say a video frame, comes into the system's memory. The RISC-V processor, which they call MyV here, acts like a traffic cop. It tells core vector blocks, hey, get to work. Core vector blocks then pulls the data and all the AI model instructions from memory, crunches all the numbers, and sends the results right back out.
Now let's zoom in on core vector blocks itself, because this is where it gets really interesting. You'll see it's not just one big block, it's actually a team of specialized units all working together, and each one has a very specific job to do. Think of it like a super efficient assembly line for AI calculations. First up, you have the manager, a small microcontroller that reads the AI model and directs the whole workflow. Then you have the all-rounder. That's a general-purpose vector processor that can handle all sorts of different tasks. And finally, for the really tough parts of modern AI, you have the heavy lifter, a dedicated CNN accelerator that is built to just tear through those incredibly dense calculations. And here is the payoff for all that clever design. Because this is all built on a flexible FPGA, designers get to choose how big they make their AI engine. They can use a smaller version, the V250, for lower power jobs, or they can go all out with the V1000 for maximum performance. And as you can see, that more than triples the frame rate on a standard AI benchmark. It's this beautiful, tunable trade-off between power, resources, and speed.
So let's recap.
we have a powerful open-source processor, we have a flexible and really efficient AI accelerator, and it's all on a single chip. Now let's talk about what this really means for the real world.
So yeah, why does all this tech matter? What does this new power couple of technologies actually enable in the devices that we see and use every single day?
This technology is aimed squarely at what we call the edge. That just means it's for devices that are out in the world, not sitting in a giant data center somewhere. We're talking about way smarter security cameras, more autonomous drones and robots, advanced driver assistance systems in our cars, and the entire next generation of factory automation. All of these things need serious compute power, right where the action is happening. You know, here's the crucial point. Features that were once kind of niche, reserved for military and aerospace applications, I'm talking extreme power efficiency, ironclad security, and unwavering reliability, those features are now essential for pretty much every connected device. The demands of our modern world have made these things mainstream.
By bringing together a customizable, real-time processor with a powerful AI engine, all while keeping power use low and security high. Well, the PolarFire SoC is basically a recipe for innovation. So it really makes you wonder, right? What new category of intelligent devices is going to be built on a foundation just like this one? That's the big question this technology leaves us with.